Let's start with the fourth definition of beta. The fourth property actually gives us how to find out the value of beta function. So this is pretty much important property. This gives us the relation between beta and gamma functions. Okay, so particularly the relationship between beta and gamma function is beta mn. This is given by gamma of m into gamma of n divided by gamma of m plus n. I hope everyone remembers the definition for gamma function. Gamma of n plus 1, this is given by n factorial, right? Please recall the thing. So this is nothing but m minus 1 factorial into n minus 1 factorial divided by m plus n minus 1 factorial. So for example, say I want to find out beta of 4 5. So in that case, what is it? This is 4 gamma of 4 into gamma of 5 divided by gamma of 4 plus 5 is 9. So this is nothing but 3 factorial into 4 factorial divided by 8 factorial. So using this particular property, I can directly figure out what must be beta of some numbers. Okay, so while solving examples, we are majorly going to use the same property. Okay, so while solving examples, firstly we are going to compare the given equation with the definition of beta, and if it matches with the definition of beta, we are going to figure out value of that beta function directly using this property. So that's why this property is pretty much important. Okay, everyone remember the gamma of half is given by root pi. The same property I am going to prove using this property. Okay, so particularly I am going to use a definition of beta, that is p plus 1 by 2 q plus 1 by 2. This is given by 2 times 0 to pi by 2 sine raised to p theta into cos raised to q theta d theta, right? Particularly I am starting with this definition of beta. I am selecting this because when I am substituting p and q both equal to 0, what I have here, beta of half comma half, this is equal to 2 times 0 to pi by 2 sine raised to 0 1 cos raised to 0 again 1 into 1 1. So just evaluate the integral. This is 2 times theta 0 to pi by 2. So this is 2 times pi by 2. So just pi, correct? And on the other side, this is beta of half comma half. I am going to use this property here. How to use that? Beta of half comma half is going to be half gamma of half multiplied by gamma of half divided by half plus half, that is 1. Gamma of 1, everyone knows this is equal to 1. So particularly what I am having here, gamma of half whole square is equal to pi. So what is it equal to? Gamma of half is same as root pi. Okay, the proof for this is also important, so please keep in mind how to prove gamma of half is equal to root pi. Then the next property, last two properties we are going to use without proof. Next property is gamma of p multiplied by gamma of 1 minus p. This is equal to pi upon sine p pi, where the condition on p is p must be in between 0 to 1. Okay, so whenever I want to find out product of two gamma functions, okay, so in that case, if p is in between 0 to 1, then I can directly conclude that pi upon sine p pi is nothing but product of two gamma functions. Okay, for example, say I have 5 by 6 and this is say multiplied by 1 by 6, and say I want to find out what it equal to, right? If I keep this 1 by 6 as it is, and if I writing 5 by 6 as 1 minus 1 by 6, so this is nothing but 5 by 6, so clearly this is same as this. So in that case p is also strictly less than 1. What is the value of p here? 1 by 6, right? And which is clearly greater than 0 and less than 1. Correct? So in that case I am going to substitute directly value of p here. So this is pi upon sine of pi by 6, and that's it. So substituting value of sine pi by 6, I'll get the value. So sine pi by 6, substitute the value so that you can just get the value of product of two gamma functions. Let's see. Okay, and then the last property, this is just for completion. There is no example based on this last property. The property is not that important, but let's complete it. The last property is called as duplication formula of gamma function. Okay, the formula is given by gamma of m multiplied by gamma of m plus half. This is equal to root pi divided by 2 raised to 2m minus 1 into 2m, gamma of 2m. Okay, the last property is not that important. Up to this, every property is important, because every property we are going to solve each example on each property. Okay, so before solving examples, you need to go through this video. You need to know all the properties, and then we will start solving examples. Yeah, okay.